Uh, Thank you for attending today. And I'd like to introduce what we are trying to do. Because the purpose of our graduate school is advanced integrated study in human survivability. And we are trying to catch up with how these complex risks and from our point of view, because I'm one of the faculty member. I cannot cover all fields, but I can try to address what I can do. So with the student, that there is a contributor. It's Moe Fujita, the former our PhD student. Kiana Tomita is current PhD student, and Tatsuhiko Sato, he's a JE visiting professor at Kyoto University and Emika Fuji. Okay, so this meeting, what we like to focus on is how can you distinguish several different risks? There is a natural hazard, an anthropogenic hazard, and also a space-based hazard, and warfare, and also the AI fear. We couldn't address those warfare risks, but I hope during the discussion there is a specialist will be talking about the security risk issue. And also the purpose of this symposium is how to integrate diverse risk domain into the single conceptual framework. And that is a very controversial step, but I would like to propose one. And establish a unique prioritization, logic access, natural, anthropogenic, and warfare risk. And policy related risk government model and the human survivability. But before, we have to address what is a natural disaster. There is a conventional or the current ongoing natural disaster. There is flood risk, earthquake risk, tsunami risk, and epidemic risk, storm risk. This is actually its current ongoing. So we have to face, this is real. And not only that, there is a bear risk, wild animal risk, and a new risk is coming. So in the daily life, we have to think about this conventional natural disaster and also. But there are some low probability, high consequence events, which include asteroid impact that has been focused on by Professor Yoshikawa. He is raising awareness, including the Vladimir, also saying it's a huge risk in terms of the number of people when it hit, but it only hit within 1 million years. So normally you don't realize those risks. And solar superflare, of course, the superflare happened 1,000 years ago, and that normally doesn't happen, right? And the supervolcano is mean the Mount Toba. And have you ever heard about Yellowstone? Yellowstone and Mount Toba is the only two supervolcanoes which is still active in the current Earth. So that they are risking our future, but normally you don't have to worry about it because it's very, very long time. But not only that, there are a number of new anthropogenic risks. Dr. Morishige addressed the AI system. Of course, it's not only risk, it's of course it's a benefit, but the benefit turns into the risk if you cannot operate correctly and if you have no access, there is a big gap. And global cyber failure, that might be a big one. And the industrial biological mega access. And not only that, we have a warfare risk. This is very, very serious. Nuclear conflict and technological and tactical nuclear use, right? This is really, really, we want to try to avoid 100%, but no, it is really risk we have to think about it. And also, there are potentially space warfare. Fortunately, space warfare is still not ongoing, but there is a potential risk of the satellite killing satellite. And then the AI-based escalation loop. And autonomous weapons. If this is a story of Terminator, so they decide by themselves that the human is a risk factor and they start killing us like automatically, and that is a kind of unthinkable, but it's a very, very risk. So, for example, showing this is a very simple slide, but there is a global natural risk, flood happening every year, earthquake every 10 years, typhoon every year, and drought every 10 years. But besides, there is a global anthropogenic risk. It's a climate change is ongoing, a nuclear war ongoing, but we don't know when. And hopefully it's never happened, but the risk is there. And AI risk is when. When the singularity happens. I thought it has already happened, but we don't know what the singularity is. It was discussed, the singularity happened in 10 years or 5 years, but it looks already happening, but we don't know. And pandemic is already happened. This is a completely different risk for the space that we have discussed. The asteroid attack, 1 million, 1 per millions. And super flare is real. But those risks, it's not the daily risk, but it's a real risk. But it doesn't frequent so much, right? We can forget about that, but it's existing, right? So let's think what is anthropogenic risk and the environmental anthropogenic risk is a human-driven climate change, biodiversity collapse, large-scale resource depletion, and technological anthropogenic risk is AI system and global fiber infrastructure collapse, and the industrial technological mega accident might happen anytime. And also we have to think about warfare risk and strategic warfare, a nuclear conflict, PMP attack. It might be serious if you kill all the data center and also the circuit by EMP. That is very, very bad news, right? So if we lose all the bank account information, how can we survive? A space-based attack that I will introduce later, but anti-satellite, right? And Kastner syndrome. And also information and cognitive warfare, right? So that is like, it is related to the network and the AI also, and hybrid risk. They are all related. And I will also say that nuclear disaster, nuclear power plant disaster is a hybrid risk between the earthquake and that kind of thing, right? Just for the information, what is the anti-satellite weapon? Actually, we have so many satellites orbiting around the Earth, right? So if one country trying to destroy other satellites, their satellite will be vanished, but very, very small particle is distributed in the place. But they will never fall down. They will orbit and stay in the orbit. And someday, if you want to eject the spacecraft, they eventually hit the aircraft and destroy. And that is a very dangerous thing. So what is the Kastner syndrome? So if you increase the number of the satellite, like SpaceX is doing, right? So it's 1,000 satellites, 1,000 and 10,000 and 20,000. And how can you will control? Because they will never fall out. They are trying to fall down by themselves, but if they stay there, how can we control the low orbit, right? And that is a very big risk. And also the relationship, these are very, very strongly related to, right? Okay, so coming back to the natural risk, the asteroid and natural risk can be considered as this is let's start with the natural risk, the space-based risk that we have calculated, like LPHC, HPLC, and risk map. So this is actually the study with Moe Fujita, but doing the sports sector, like frequency and severity, right? If you have a high frequency risk, so you have to avoid the risk, and severity is high. But for example, if you have a low frequency and high severity risk, that is a very big issue, right? So for example, if you have a high frequency, high severity, you can only avoid. No one will think about living in the volcano's mouth, right? And also, if you if you want to live in the Kilauea and there is a mouth of the volcano, no one will think about it. But for example, if you go to the Mount Aso, right? Many people if you go to the Hakone, you are living in the volcanic. It's a caldera, right? We call it. It used to be a volcano, right? But it will only erupt once in 10,000 years. So no one will worry about that because living. So that is depending upon the frequency, right? So the frequency and severity is very important factor, right? And because of the shortage of time, I don't get into the detail, but in the human history, not only the human history, terrestrial history, volcanic eruption and asteroid impact and climate change is the three major factors that kill all species, right? The volcanic eruption, not normal volcanic eruption, but the big one, it's more than supervolcano, may trigger extinction and also there's a catastrophe. And asteroid impact, as I told you, that kill all dinosaurs. This is the one that it's considered, it's happened only once in 100 million years, but the frequency has to be considered. And climate change is, it's normal, but it is giving a huge impact in certain systems. We may face one of them. So these are the past mass extinction event, but two of them is considered, one of them is asteroid impact, one of them is volcano, and other is considered climate change, but we don't know, right? And there are several different factors. So we just talking about Yoshikawa sensei's things. This is the asteroid impact probability, right? The point is, this is, do you remember the Yoshikawa sensei's video of the Chelyabinsk? It is happened in the Russia in 2013, February 13 or February 15. I forget, but it was almost 12 years ago. And Chikchu, this is happening 65 million years ago. And Tunguska, which happens 1908. So actually, we have only these three events which can be considered historically. This is a proof of the real impact, and we can evaluate how big it was. And by considering these two, you can write these kind of curve. This was proposed by the different researchers. But in the reality, there should be many small asteroids. So the point is whether if you have like a Bennu, it's a 500 meters asteroid, and 460 feet, it's an asteroid is 140 meters asteroid, right? That Yoshikawa says. So if those happens, we don't know how frequent they happen, and because of the gap of the statistics. So the only thing we can do is you can make a precise calculation. But we are doing the kind of evaluation by not using that. But just for the giving idea, this is a very important thing. You have a Hiroshima atomic bomb energy is, if you consider one, the Chelyabinsk is 33 times larger. Why 33 times larger? No one killed, because they exploded above the sky, right? And they only broke the window, but energy itself is very huge. And Tunguska event is actually 1,000 times larger. And if you think about a nuclear war, nuclear winter, this is like, it is considered, is almost 600,000 times larger compared to Hiroshima bombs. It happens. But think about that. The Chikchu crater which killed all the dinosaurs, is in terms of the Hiroshima bomb number, it is E power 10th, right? So it becomes 100 billion or 100 billion times or 10 billion times or 100 billion times of Hiroshima bomb. It's a very huge energy if the asteroid with a 15-kilometer attack. So this is the end of the world, probably for us. So of course, for that, they are trying to avoid how to escape from that. For example, this is an estimation that we have calculated, like how much the asteroid really, but this is a kind of the calculation, how much economic loss happened by flood and tsunami and terrorism and Ebola and climate change. This number is a little bit old, but to give an idea how those events are serious, you can think about it. What we did is, the thing is, insurance mechanism for LPS disaster. I was very shocked, Yoshikawa sensei saying that who is paying for the unprecedented defense, and no one. And he is saying the JAXA is paying and NASA is paying. But the reality, we have to think about establishing those risk events, right? So for example, if you have like a small scale, you can have an insurance reinsurance, right? And this is, I think, a specialization. Kadama sensei, probably he knows more about that, but our is very simplified one. But if you have more bigger scale, there should be international donor assistance. And also now, if it's bigger than that, you have to prioritize which event you will be focusing on. The prioritized assessment is should be the top and government-backed disaster, and also the international risk pooling and the parameter insert. And also those kind of different prioritization assessment is important, and also the disaster compensation is also the second one, and the international risk pooling, and also the parametric insurance should be the trigger base. And these should be made. For example, by making 4-layer, we did a hypothetical risk analysis for the asteroid. For example, you can classify to the different size of the asteroid, 30 meters, 30 to 80 meters, 80 to 150, 150 to 30, and from the 500 to 1 kilometer and more than 1 kilometer. And then you can determine. So this is actually rough one. It's having every 100 years, every 300 years, every 2,000 years, every 100,000 years, and this is every 100 million years. And then the impact energy, and then you can have an insurance rate, and which, for example, the Chicxulub event, it should be the rare one, you cannot think. But what we did is you calculate the urban heat, ocean impact, and also the remote run and not, and then divide it into the Earth round column. And then if we calculate, you can have an estimated cost, right? And by this calculation, we made expected loss is a maximum at the bend class. So if you have to think about, if you only focusing on the economical point, you really need to focusing on the bend class event happens and try to avoid. So which is the Chicxulub class, you cannot have to escape. It's too big and too expensive. But the bend class event may happen, and also the 100-meter class of the satellite may happen. This is very preliminary calculation, but I think it's the first calculation which address the economical loss and also the expectation for the size of the distribution, right? So this is better focusing on the medium-sized asset. So this is one example of our approach, right? But we want to, for example, this is a different example of the, it's Vladimir say about the space radiation by the cosmic ray and also the super flare. During super flare, if you fly between the New York to Narita, it is an exposure of the galactic cosmic ray with a normal without a solar flare. But if you have a solar flare, the dose increases, right? So please do not fly during the aurora borealis happen. I fried. But it is, if you fly above the 12 kilometer above the sea level, it is not so risky. It is sometimes 3 times, 4 times risky. But if you are a rich person, if you want to space flight, then it's a disaster happens, right? So you will be exposed at a huge amount of the radiation, like 159 millisievert. This is not fatal, but still it is better avoiding risk. And that kind of calculation we are doing with Sato Sensei and Fujita Moe-san and Fuji-san. Okay. The other one, the unified global risk. This is a very difficult thing. How can you make into the two? And for example, I am proposing 2 different things. One is like a 3-axis global risk framework. One is a natural anthropogenic. Axis 2 is terrestrial and space-based and cyber. So that axis 2 is a terrestrial risk. This is real risk for us. The space risk is still real, but it is far from us, but it's impacting. The cyberspace, this is invisible, but of course this is real. Not real, but it will affect us. And cognitive risk is too, right? And also the propagation, you have a local, regional, and systemic and global, right? So if you choose a risk, you can divide into very different things, and also this should be focused. The next one is a very simple unified mathematical risk modeling, but it looks like this. The risk is the annual probability direct to physical damage and systemic vulnerability and global inequality multiplication, and C is a cultural impact, right? But it's so general. But you have to think at least these factors. The next one is more important. We like to focusing on. If you think the risk factor, the AI-based anthropogenic risk, there should be 1 E. This E is 1. It's a human factor. If this is natural disaster, E equals 0. But if it is anthropogenic risk, this E become bigger and bigger, right? Depending upon the factor. Like AI is 4 to 50. Nuclear escalation is 100 to 200. So which means the risk can increase in the human factor, and you have to think, this is not physical thing, but it's a reality, the risk increases. So that is a new way of thinking I would like to propose. Of course, the natural risk can be calculated by the probability risk, but the human risk may amplify depending upon how. This is very uncertain, but you have to think about, right? And there is a risk probability index, there is a high risk probability, AI, medium as nuclear and solar proof of air, and medium is a pandemic and climate change and cyber graph. And low, but this is not low actually, earthquake and flood and typhoon. Actually, this is the real. So we are saying, so if you take a look at this, are you really seriously thinking the earthquake is a low risk probability index? I'm not saying that. Because normal person can realize easily the earthquake is a risk and flood is a risk, typhoon, it's a real risk. But think about unrealistic cyber, those risks that can be only be imaginary, and that has to be focusing on in a different way. That's why I am proposing like this way. And also there is a technical resilience and social cognitive resilience and economic. So resilience is a very important thing, how to avoid those kind of things. Actually, to value the resilience is very important. So we are now trying to validate the resilience in the community and the sectors. So this is one picture doing with the Kiana Tomita is about the language analysis and also the cross-sector resilience mapping using language model. But this is like how to divide the different sector by the interview. And the full work will be presented by herself, but I'm just showing this one of those. Right. The conclusion, the Kyoto prioritization framework, the key outcome, unified risk priority index for all major hazard types. There is an integrated global risk knowledge base and also the escalation monitoring for warfare and AI, and core AI governance principles, and space-based early warning and low probability, high consequence financial mechanism, and Kyoto, our role, and how linking planetary defense and space weather, AI safety, and nuclear risk, and provide a unified mathematical policy model. I know this is difficult, but we have to think. And multi-domain risk and interrupted, and more here, and AI require escalation modeling. And that is important. And during this writing this, I am always thinking, why not you asking ChatGPT for the risk evaluation? You can ask for the ChatGPT because they know everything. However, you need to evaluate the AI risk. So you cannot ask AI how dangerous you are, right? So that is a very complicated paradox. Of course, we need a complex AI system in order to evaluate, but we have to at least having one index which can be visible for us. Not if you make a very complex system which only AI can understand, we cannot handle. So you have to try to simplify and find a solution by yourself. Okay, thank you very much. Thank you. So if you have any questions and I would like to answer, I'm sorry, I am talking so exaggerated things, but if someone can make some comment of the question, I hope. Yeah, Morishige-san, please.
Yes, thank you for your talk. My question is, in my industry, the biggest risk is cyber attack or cyber security. And if you are gonna put the E factor on cyber security, what would the number be?
Oh, I didn't calculate the cyber factor for the E, but this one, I would say it's 100 around. But this is very preliminary. I didn't do any precise report, but I am proposing that the E factor should be considered. It is very different from the normal system, but you have to think, right? Okay. Thank you. So if you have any question to ask, okay. Nice. Any question and any comment, I'm very happy to answer. I don't know. About moreなんか言ってよ。言ってよ。そう、じゃあ一つ。せっかく。
Thank you. Yeah, Yamashiki sensei. Very, very interesting presentation. I really learned a lot. Are these risk models shared internationally, and how do each country react to these risk models?
No, I didn't see the for comprehensive risk model yet, because I think the Cambridge University and our group, and also the only few universities looking for comprehensive risk analysis. And this is not very popular, but it's increasing now. Because what is increasing? How to validate, how to visualize like anthropogenic risk, like AI risk, warfare risk, among other risks. All are risks that you have to deal with, but we need to unify because each person working in the different axes. Okay, thank you.
Thank you, Yamashiki-sensei. I had a question with the universal formula, because also related to my research with nature, for example, the cultural aspect of nature. How do you index cultural and religious thing, for example, because we have to rate it from 0, 1, 2, 3, but how do you evaluate this kind of thing and not go to soft physics and soft mathematics, but how do you scientifically evaluate those kind of things?
Actually, this is just an outright proposal. Probably I have no capacity to get into the detail of the culture, but I understand the cultural factor is really important, and the religious factor is important when you wanting to implant like a risk factor among the community, that this might be the one. And I really want you to contribute if possible. But yeah.
Hi, thank you for your presentation. I think just to comment on the last question, and maybe using the risk aversion used in economics and finance probably would be useful, especially risk aversion between countries that can be very well evaluated. So that could be maybe useful to your work to see the cultural differences in how people are risk averse and how they would value different kind of risks, be it they are mostly considered on the financial side, which is limiting, but still it could give you an idea, a general idea. Yeah. Thank you.
Yeah, actually, that kind of thing, I am trying to get into the things, too complex still. But I know that we have to work in the collaborating manner. The biggest issue is many people propose the different, completely different equations. They will never discuss each other. So, but if you propose something, it's a universal, then you can discuss and improve it. But thank you. Okay. Oh, we are now. So.
Thank you very much for your very interesting presentation. I just know that you have communication with the Center for Existential Risk, Cambridge University. I was wondering, do you incorporate their concepts, their way of thinking somewhere in your framework?
I think yes and no, because some of the research actually was made since our last visit to Cambridge. With Fuji-san, right? So because what he was doing and attending the annual conference was very, very instinctive, and how they have plenty of study about the wide range of study. But the most serious issue at that time was warfare and nuclear war because of the Russian and also the Ukraine issue. If we have now, then the topic may change a little bit. But we are trying to cooperate and also different.
I was also thinking whether you have some analysis of the interaction between different types of risks, because in the morning, Vladimir talked about the solar flares, and he mentioned the solar flares can lead to some weapons exploding.
Yeah. No one think about actually.
So one type of risk is actually related to another type of risk.
Probably, yeah. No one think about that. The Vladimir was pointing a very scary risk. So yeah, if the nuclear system was disturbed by the solar flare, that is a big nightmare that we have to think about. Okay, thank you very much.